Welcome back, dear students. Welcome to the second video of this chapter. This is a continuation of the last video where we have learned about motion. So let's get a quick recapitulation of that. In the last class, we came to know about motion. What is motion? What are the different types of motion? And there I told you about that motion is defined as change of position of any object with respect to time. If anything is moving, then it is said to be in motion. There we came to know about the types of motion, which were translatory, rotational and periodic motion. Then we came to know about non-uniform motion, like if a body covers unequal distance in an equal interval of time, then that motion is said to be non-uniform. Then linear motion, where the motion was in a straight line. Then again came your uniform motion, if regular in regular interval of time, if a particular amount of distance is covered, then that is uniform motion. Then we came to know about physical quantity, which were divided into scalar and vector, scalar quantity and vector quantity. Then we came to know about distance and displacement, where I told you that distance is a scalar quantity and displacement is a vector quantity. Displacement is the shortest distance traveled. Then speed was distance traveled by time taken, and average distance is calculated by the formula total distance by total time. Next is your acceleration. Acceleration means the change in velocity and divided by the time taken, that is defined as acceleration. The symbol used for acceleration is A. And change in velocity. Change in velocity means what is the initial velocity and what is the final velocity. The initial velocity, the symbol used is U, and the final velocity symbol used is V. And total time taken, that is T2 minus T1. Now comes your uniform and non-uniform acceleration. Just as in case of uniform and non-uniform motion, you had that if equal interval of time, in equal interval of time, equal amount of distance is traveled, then that is uniform motion, and the vice versa was non-uniform motion. Similarly, here is uniform and non-uniform acceleration. Like if the rate of change of velocity remains constant, then that is uniform acceleration, and if the rate of change of velocity is not constant, then that is non-uniform acceleration. Next is your the first equation of motion. I told you that there will be three equations of motion which we need to derive. Then the first equation of motion is v is equal to u plus at, and based upon this we have to do certain problems, and certain mathematical problems we'll be doing based on this. So here the first equation of motion is given by v is equal to u plus at, where v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time taken. Now this is how the means derivation is done here. This you just see in the video. For the notes purpose, I will give you in writing in the PDF form. Here it is like acceleration is defined as change in velocity by time. Now they have been replaced. Acceleration is equal to change in velocity means what was the final velocity minus the initial velocity. Then the symbol is used here. In place of acceleration, they have used a. We have used a. Final velocity is v and initial velocity is u by t. The formula becomes at is equal to v minus u, and there is just a replacement, just a simple substitution. This v u is taken this side and it is written as v is equal to u plus at. This is the first formula. The second equation is given as s is equal to ut plus half at square. This is a derivation which I'll be giving it to you. Just some assumptions are made, like initial velocity is u, final velocity is v, the acceleration is a, and based on that average velocity is equal to initial velocity plus final velocity by total time. Means what is the average velocity? Then here average velocity is u plus v by t. Then using this, the distance traveled is again equal to average velocity into time. So distance is shown by s. So average velocity is equal to u plus v by t into time is t. Then just replacement is made and we obtain the second equation of motion. And the third equation of motion is v square is equal to u square plus twice as. Now for the derivation of this equation of motion, we need to use the previous equation of motion, that is the third one, which is s is equal to ut plus half at square. Using this equation of motion, and from the first equation of motion we got v is equal to u plus at. Now rearranging this one, from here the value of t is derived. Now this value of t, it is put in place of this t here. These two t are replaced by the values v minus u by t, and we have obtained this third equation of motion. This is the third equation of motion. Last topic is here your circular motion. Now, a body is said to be in circular motion when it rotates about a fixed point. Like in a circular motion, the velocity can never be constant, but the speed of the moving body is constant. Means the velocity is not constant. It's moving in this side, then the velocity is different. Like if it is tilting this side, the velocity will be different. Again, in different direction, the velocity is different. A body moving in circular path at a constant speed is said to be of uniform circular motion. Means the speed is constant, the speed is fixed, but the velocity is not fixed, because at every position the distance is changing. The direction is changing, and here the velocity v is equal to 2 pi r by t. This was your circular motion. So this is a very short chapter, where now in the next day I'll be giving you the notes of all this chapter, but you are asked to read the chapter once again. Thank you for watching the video up to here. Thank you very